The following question is from Spring 2012, Math 115, Test 4. In this video, I will do number 10, 11, and number 12. Number 10, factorize completely. Especially when you see completely, be aware that you may have level 1, the greatest common factor, factoring thingy. And you can see that I can take the 2 out and also the x, right? Let me take the 2x out. So the first term becomes x squared minus 32. Okay? Now, because this is 2 terms, then we need to be aware that this is possibly difference of squares. Now, the thing is like x squared is a square, but 32 is not a square. Okay? If this were, let's say, 16, then you can do difference of square factoring. But this 32 is not a perfect square, so we cannot go further. This is the final answer. Okay, that's the furthest we can go. Number 11, factorize completely again. You see, let's see if we have common factor. We have only x here, but this doesn't have x, so we don't have common factor here. Now, on the other hand, we see that because this is 4 terms, we should be aware that this is very likely factorization by grouping. Now, in the first half, I will take x squared out, and I have x plus 3 left inside. Okay, and for the second half, I will take, I think I can take negative 16 out, and I have x plus 3 left. Now, notice that there's a change of sign when you take negative 16 out, right? This will not be negative anymore. It should not be x minus 3. It has to be x plus 3, okay? Because you take the negative out, right? Now, from here, then let's finish up the grouping, the factorization by grouping. I take the x plus 3 as the common factor out. I have x squared minus 16 left inside. Now, at this point, factorization by grouping already done, already finished. But when we take a look here, x squared minus 16, it is a perfect square, right? So I can go on, and I should go on factorizing that as x plus 4, x minus 4. Okay, so this is the complete factorized form of that polynomial earlier. That's for number 11. Number 12, we need to divide this polynomial by this monomial. Now, because there's only one term on the denominator, then what I will do, I will split them up into the sum or difference of rational expressions with denominator 24xy in this case. Okay, on the numerators, we have 9x squared, then minus 8xy, and then here I have plus 12y squared. Now, what I will do next, I will simplify each rational expression. Here, I can reduce by 3x, I believe, so this becomes 3x, and at the bottom I have 8y. Okay, so imagine if you divide the top, for the numbers you reduce by 3, and for the variable you cancel 1x, right? Now the second term, 8 and 24, it becomes 1/3, right? And then as for the variables, x cancel, the y also cancel, and therefore I put 1 on the top there. Now it doesn't become 3 though. You see the 3 was actually on the denominator, and if you have nothing on the top, you need to write that 1. Plus 12 and 24, I reduce by 12, that's 2 underneath. As for the x, it stays, and as for the y squared over y, I have y on the top there. Okay, now this is from Spring 2012, Math 115, Test 4, number 10, 11, and 12.